both mathematics and quantum mechanics, mostly quantum mechanics. And today, I want to highlight one part of what he did for quantum mechanics and physics in general. Apart from the Bose-Einstein condensate, today I want to talk about Bose-Einstein statistics. But before that, let's get to the background of who Bose was. Now, he's often confused with Jagadish Chandra Bose, who was another scientist who came from India and, in fact, was born in the same region. But with a lot of big names in physics at the time, instead of a lot of he worked on some parts of the radio receiver and didn't get too much recognition from physicists at the time. He didn't even win the Nobel Prize. So, what did Bose actually do? Well, it comes down to this. In quantum mechanics, as we've reviewed before, particles have little bits of quantized angular momentum called spin. Now, this was not known for a while, and we dealt with particles as if they had no inherent angular momentum, i.e. no spin or zero spin. So that was the classical interpretation of what was going on here. But of course, the classical interpretation was unfortunately wrong. Quantum mechanics tells us that every particle has a spin, and that spin is quantized on this ladder. This ladder going up and down in half steps. You can see why in one of our other videos. And every single particle with half integer spin is called a fermion, as you can see, named after Enrico Fermi, who also studied their properties. Everything left is a boson. As you can see, made from a combination of the word Bose, his last name, and on. Although the EO looks pretty weird for something that just makes an O noise. So it's just going to be boson. So, there we go. What's so different about bosons? Well,